So this time around I said we should try to look at making this comparison a bit better, because right now it only matches for exact things or where one is a substring of the other, but if we have a spelling error or we're not entirely sure how things are supposed to be, it might make sense that it's a bit more flexible in how it returns results, rather than just saying just only things that matches. So we might say, well, give us anything that matches over 70% or something. That would be a simple fuzzy search where we just need to count out how many letters of the two strings are the same, and then if they are, good. Alright, so names almost equal. So name input. So now rather than doing this, we're just returning our names almost equal. And so I actually haven't done this, so this will be very experimental, but we'll see how it goes. So the simple way we could just continue doing is if name includes input, just so we can confirm that things continue working as far as searching goes. Alright, it does. That's good enough for now. Then, well, we want to set some limit on, well, how equal. Let's say we want them to be 70% the same. So 0.7. And then how we need to calculate some way of getting this score. My recommendation of doing this is actually just splitting up the name. If you don't just give this an empty string, it'll actually split so you get an array with individual values. And you can do the same thing with input. And then now we need to count how many properties from values from input values appears in name values. So the easy way of doing that would be say, all right, count is 0. Right now we haven't found anything. Then this is another way of doing a for loop, is for of, which is for many intents and purposes equivalent to the good old for each loop. It's just a bit shorter, so I prefer that. And then, alright, if name values includes value, then we can increase count. We say, alright, we found it, it's there, good. And then we can, no, that's fine. Alright, now we have hopefully a count. So yeah, count. Then we just do count command name command input. Log out all of those and let's just return true. So just always have everything. We're not actually comparing the score yet. So we're not searching for anything. Well, of course. So if we actually do search for anything, we could say, alright, this contains an M, it gets a count of 1. This contains an M, it gets a count of 1. If I now do O, some of them will start getting a count of 2, and some of them have a count of 1. So you can see we get more there. So what's the max possible count we could have, do you think? So assuming that we can get
70%, it depends on the
no, just ignore this one right now. But yeah, you're correct. It depends on the string length. So assuming that we can increase by 1 for each value we have in the input, it would probably be pretty decent to assume that the max value count can be is the length of the input. So let's actually call this score instead. So max available score should be name.length. So, oh no, sorry, input.length. So how many characters there can be. And then we can say, alright, percent match, that is the score divided by the max available score. And then if we run it again, as you can see, if we don't have anything, then we get a division by 0, which we really don't want. But then if we search for M, we get a percent match of, for example, 1. Then if we search for O, then we can see we get some matches on a half. And was that a really bad example where there were nothing that matched? So what do we have that actually has an M here? So let's do ML. Then you can see for some of them we get a match of 1, for some of them we get a match of a half. And we said, well, as long as the match is better than 0.7, it's good enough. So if percent match is more than or equal to how equal, then we say this is a good enough match for us right now. So from start we get nothing. So we need a little special case here. So if percent match, number dot is, I cannot type, is nan. Nan means not a number, and that's what you get if you, for example, divide by 0, which we all know from math that's a bad idea. The world is going to blow up. In JavaScript we just get not a number, which is alright. So if the match is not a number, then we just say alright, keep it, I don't care. So then we at least get something. So we have chocolate and car. So we can search for C and we get something back. Then we can search for, say, R, and we get like car and gift card and computer. And then if we search for, say, an E, we get, so it's a bit more fuzzy in the order right now. So what we searched up there for doesn't really make sense. Like searching for CRE and I get computer and green car. It's like, what? So another way of changing this score might be saying
sequence.
Yeah, as long as it's after the previous one I found, then it's good enough. So in that case, we actually need to change this to a normal loop. It does not have a shorthand for that, because then we need to know where we are and such. So I is less than, put values dot length I plus plus, and then const value is equal to, put values at I, and then last found index is equal to -1. Oh no, let's do 0, because then it'll have some really fun properties. So then we can do, alright, we need to do an inner loop now. So the inner loop, usually you have I, J, K, and because short letters, we say, alright, this should start at where we last found something and should just continue until we have the length of name values and J++. So then we can say in here, alright, so if whatever was, so if name values at J is equal to that value we found up there, then we increase the score and we update last found index to be I, and we want to break out of this loop. So we want this loop to stop because we've already found a match. Stop searching. I don't want it to then move all the way to the end. Then again, it's another way of, more advanced way of calculating the score. So what do we have? We have a couple of chocolates. So if we just do CO, we get things like chocolate and Colleen and computer. But then if I do COE, I only get these things where it actually keeps matching up. So socks no longer matches. I'm not yeah, that still works. Should that work? we find a C there, we should not be able to find an I, but it's less matching. So this is fuzzy matching. It's a really bad fuzzy match. There are all sorts of other ways, like there's something called a chi-square test and fuzzy search algorithm. MSFT redirect. There. Way internet. So this is something called approximate string matching, which is people do research on this. I have personally for something used something called Levenshtein distance. There's an algorithm given here, rather than implementing that in JavaScript by hand. We can just Google for things, as you have seen. And then some nice guy on the internet has written these things for us. So I don't actually remember what it returns. Pretty sure it just returns a number. Returns the distance between two numbers. So this is one. Oh, that's just one way of doing it. And as you can see, it's pretty bad. It does work for some sort of fuzzy searching, and usually you would combine this with a sort. So you would both say if it matches and how well they match. We sort by, rather than just do what I did here and say, they seem close enough. So if we borrow, let's just call it that, some code from the internet by pasting it in here, and then hope that we can close that and ignore it. Then we can actually do, alright, so we get a number here called the distance from A and B. What Levenshtein's distance does, it says how many edits do I need to do in one string to get the other string.
How many what?
Edits.
Edits.
So say I have a string, I have one string called f, which has the value of foo, and another string which has b, which has the value of boo. I need to do one edit because I need to change the f to a b, or the b to an f to get the same string.
Okay.
And equivalent, if I had another letter in here, then it would say, alright, well, we can just remove that one, and that's an edit. So if I had like, what is something here I can say? I can say like this. These are completely different. So it says, alright, for the first one, I can change that to an F. The second one I can change, and the third one I have to change to. So this gets me an edit distance of 3. And I actually think it's a bit more complex than that. It doesn't actually just say I can change it. It actually says I can remove it, and then I can add in a new one.
Or switch it.
It doesn't say switch it. I actually think it says remove and then put in another one. So it goes 2 if it needs to change them. If you had OFO, for example, it's actually allowed to move it in one go, I think.
I mean switch.
Yeah, that's switch them around. So it does all sort of fancy things like this. So we can just say it's almost equal if the distance is less than 3. So that's another. Yeah, so if we don't have any input, then they are the same. Am I just really bad at getting, okay, I was really bad at randomly generating things. So now, if we search for things like carrots, so now this is really fun. I've searched for car right now, but I don't get any results still. Only until I get here, because now we can just add in 2 letters, and we have what I wrote. So then the difficult things up here becomes, well, what is that limit? And really, I have no clue what a good limit would be. I would maybe go with input.length. No, that's a really, really bad limit. So using these things correctly, messing around with them. What Google does when it says, "Did you mean this?" That's impressive, because it's really difficult to do.
Yeah.
And there's products that earns a lot of money that just focuses on being able to do a fuzzy search. Because as you can see up here, it's really, really difficult to do well. You can do one that's really bad pretty easily, but doing one that works and works correctly, not easy. Lots of money to earn there, lots of academic material to write. You can just see here, like, just how many samples Wikipedia gives. These are just examples of algorithms for doing this. So finding a good index score for that, good luck. So anything else you want us to have a look at today? Otherwise, I would call it a day. And then next time we'll be starting up on JavaScript Module 3. According to Marie, we'll be having a teaching assistant coming in and helping. She needed to finish some minor talks with her, but hopefully.
So you're not going to teach us JavaScript 3?
I'm going to teach it. She's just going to be here to help.
Oh, okay.
Unless you don't want me to, of course.
No, quite opposite.
So, any other questions?
I would say pedal to the metal, but that's not really your problem, is it?
No other questions for today? Or we'll just stop?
No.
Yeah.
You're broken now.
Yeah.
Yeah, we're
Total.